first, what is ColdFusion Security Analyzer? So let's start by getting a fair idea on what the Security Analyzer is. So the ColdFusion Security Analyzer is a static analysis tool that's built into ColdFusion Builder extension for VS Code. So what this analyzer does is it scans your CFML project source code, that is your CFM, CFCs, and it looks for security vulnerabilities before you actually deploy that code. So you can think of it as having a security focused code reviewer, right? So it identifies the exact line of code that's vulnerable. It tells you what kind of attack it's susceptible to, whether it's SQL injection, XSS, command injection, whatever it may be. And it categorizes it by the severity, that is high, medium, or low. Now, Analyzer doesn't just point out the problems, but it also suggests you on how to fix them. So every finding comes with a remediation suggestion, and then there's also a reporting side. So results show up in a dash in the dedicated panel inside VS Code. So you can double click on any issue and it will take you straight to that line of code. And you can filter by severity, by file, by attack type, and so on. And it also allows you to mark issues as fixed or ignored, and that status will get maintained in the next run as well. Now let's see Security Analyzer end-to-end workflow. So here we will see the analyzer in action, that is from when you start the analyzer till it finishes, and see what's happening behind the scenes. So here the color coded blue will be the developer, that is you, who will be working from VS Code, and the ones in orange are ColdFusion server, and the ones in green will be the results and actions. So let's start with step 1, where it starts with you, that is a user in VS Code, and you have got your ColdFusion project open. You right click on the project or folder or any individual file that you want to scan, and you simply right click on it and select Run Security Analyzer, and that's it. So that will be the trigger to start the analyzer. And behind the scenes, VS Code sends a scan request to your ColdFusion server using RDS, which you configure while adding your server. And then comes step 2, that is where your ColdFusion server picks it up. So on the ColdFusion server side, the security analyzer servlet, which is built right into the RDS layer, picks up that request. It checks that no other scan is already running. And if the server is busy, you'll get a clear message back saying the analyzer is already running. And it sends it back through the same RDS channel. Otherwise, the scan kicks off right away. Then comes step 3, that is file discovery. So the first thing the server does is walk through your entire project folder recursively and discover every single CFM and CFC files. And it also sends that total file count back to VS Code so that you can see a progress bar from the very beginning itself. And then we move to the step 4, that is parsing the code. So now here's where the actual work begins. The analyzer actually parses each file, and it does this in parallel so that multiple files at one is parsed, and this makes the process faster as well. And each file gets passed into an abstract syntax tree, and we apply all the enabled security rules against that tree, and files are processed in parallel for speed. And as each file completes, the findings are streamed back to VS Code in real time. Next is running the security rules. So once the parsing is done, the analyzer runs all the 17 security rules against it, and each rule is designed to catch a specific type of attack like XSS, SQL injection, command injection, path traversal, weak cryptography, CSRF, and more. And this is a key part. The analyzer doesn't just look for dangerous function calls sitting in your code. It also traces how untrusted user inputs travels through your applications. So if someone submits a form value and that value passes through, let's say, 3 functions, and ends up in a database query without being sanitized, the analyzer will catch that. Next comes step 5, that is recording the findings. So, as the vulnerabilities are found, they are stored immediately, and every finding includes the exact file and line number, the severity level, whether it's critical, high or medium or low, and the specific attack type. The next is step 6, the real time results in VS Code. Now we are back in VS Code, and the extension will be polling the server over RDS every second, sending lightweight status requests and pulling back the new findings as they come in. So you'll see a live progress bar. And when the scan completes, the extension pulls the full result set from the server, again through the same RDS channel itself. And you get the complete picture inside VS Code through charts. So you'll see the total number of issues, the severity breakdown, you'll see the distribution by attack type and so on. And you can also filter these issues by the severity, attack type and so on. Now, once you have the results with you, there are 3 kinds of actions that you can take. So one is jump to code, that is click on any issue and you're taken to that exact line. And second is mark the issue as fixed or ignored. So you can mark a particular issue in any of these states, that is fixed or ignored, and that status will carry over to the future scans as well. And the third is export the whole report as HTML or PDF or Excel sheet for your record. Now let's move on to what's new in Security Analyzer. So now that we already saw how the analyzer actually works, let's talk about what's new. So there are 4 major items that I would like to cover. So these are the things that we have added newly as part of the update. So first is performance optimization. That is, we have done a lot of performance optimization and improvements around this, which I will show in a bit. And we have UI improvements. That is, the VS Code extension has been redesigned to give you a much better developer experience. And we have new rules. That is, we have added 8 new security rules in addition to the existing ones. And the fourth is reporting. That is, we have added some new formats in which you can export the analyzer reports. So let's start with the performance optimization. So let me show you the numbers first. So this chart compares an older released build against the new build across some of the complex projects. So here the red color in charts represent the older ColdFusion build and the green represents the new one. And the improvement, as you can see, is pretty significant, right? So the ColdFusion projects with about 20K CFM CFC files currently get scanned in about just 10 to 12 seconds, whereas earlier it was taking about 2 minutes. And 100K file scanning is currently being done in just about a minute. So overall time wise, we are seeing a pretty good improvement, that is anywhere from 3 to 20 times improvement depending on the size of the project. And it's not just faster, but it's also leaner. So as you can see in the second graph on the top right, so the heap, so that graph is for the max heap, and you can see the heap usage currently is roughly half of what it used to be, even for large code bases. For example, at the end you can see for 100K, for 120K files, the heap usage is almost half of what it was. So this is the performance numbers for you. And as we already saw, for large code bases, there has been a significant improvement in terms of execution time and heap used. And Security Analyzer can now handle very large code bases without running out of memory. And even if JVM starts running low on heap, the scan stops gracefully, and it also gives you a very clear message about what happened, as in it clearly says that your JVM has gone out of memory and what you need to do, that is you need to go and increase the max heap, and it will also give a clear message for the unscanned files that these are the files that were unscanned, and the reason for it being unscanned is because your JVM went out of memory. And then you can also enable or disable individual rules. So in your CF installation lib folder, you can see the relative path I've mentioned here. So you'll find a JSON file called as code analyzer rules.json. So every one of the 17 rules that we have, they have an enable flag. So if a particular rule doesn't apply to your environment, you can simply set it to false. So for example, we have currently added a new CF specific rule for unscoped variables. And maybe you have got a lot of unscoped variables in your code base, and it's a legacy app and you're currently not ready to address that change yet. So in that case, you can simply go to the JSON file, and for that particular rule, set the enabled to false. And after that, the analyzer will skip it entirely, so that in the next report that's generated, you will not see a lot of these unscoped variables being flagged. And this would also make your scanning faster. And finally, the reporting. So even for projects with tens of thousands of issues, the full report is it loads quickly. And yeah, these are about the performance improvements. Now that we have seen performance, let's get to the second part of the improvement that we have done as part of the update, that is new security vulnerability rules. These are the new 8 rules that we have added in addition to the existing ones. So first is command injection. So it detects when user input can trigger operating system commands on your server, and it's actually one of the dangerous vulnerabilities, the command injection, which can give attacker full control of the machine. And next we have template injection. So this detects when user input can cause ColdFusion to evaluate and execute arbitrary code. It covers evaluate function, dynamic includes, and CF module with untrusted input. And we have JavaScript injection. So this detects DOM-based attacks, dangerous use of eval function, prototype pollution, and open redirects. And it also covers client-side storage injection and unsafe use of browser web APIs as well. And we have path traversal or file injection. Uh, so the uh, so it detects file operations where user input could access files across files outside the intended directory. It covers CFzip, CFFTP, PDF, image, spreadsheet operations, and more. And we have XML security. It detects XML parsing configurations that are vulnerable to injection attacks. We have weak cryptography. So the flags used of outdated algorithms like MD5, SHA-1, DES, and hard-coded encryption keys. And we have LDAP injection. Uh, so it detects when user input reaches LDAP queries without proper sanitization. It covers both tag-based and script-based LDAP operations in ColdFusion. And then we have unscoped variables. That is, it's a CFM specific rule. So here's the thing about ColdFusion, and I'm sure you're aware of that, that if you reference a variable without specifying its scope, ColdFusion has an implicit scope search order. So it checks URL, forms, cookie, client, and other scopes. And we do not recommend these unscoped variables due to its potential risks. So we have now added this unscoped variables into our ColdFusion security analyzer so that you can easily scan your code, and it will flag all of the unscoped variables and you can fix it so that there are no unscoped variables in your code base. And just to be clear, all the existing rules are still there. Like we had SQL injection, XSS, CSRF, insecure cookies, password handling, file upload validation, get versus post, unsafe redirects, unnamed applications, and all of these rules are still intact. And we have just added these 8 rules along with the existing rules. Now let's move to the third part of what we have added newly in Security Analyzer, that is VS Code extension UI improvements. So the reason we have made these improvements is to improve the developer experience. So this is what your current live dashboard looks like. And here, if you can see here on top, I have scanned about 100K files, and you will be able to see all issues. And we have high severity, medium, low kind of separation here. And there are also charts which represents different things. That is, here the issues are categorized based on severity. You can see the high, medium, low issues. And we have categories based on attack types, that are the different types of attacks, that the vulnerabilities that it has found in the code. We have status, we have issue type. And we also have an advanced filtering. That is, currently I have filtered this particular report based on severity low, and I have given issue type warning, status to fix, and attack type excesses. And it will only show me the data based on the filters that I've applied. And this is issue detail view, where you can see all of the issues as in the CFM files that got flagged, and this is expandable, and you'll be able to see the line of code and more details on it. And we have attack type, we have issue type, severity, and actions. And these are the unscanned files, and you can see here on the left the reason why the files were not scanned. And here you can see the name of the file and the reason, and also the path. So this is an unscanned file related information. So I will be showing more on these, all of these things in the demo. So currently let's move to the report generation part. So again, the same UI, where you can see here on top there's an export report button. And earlier we had HTML and JSON formats in which you could export the report, but we have also added PDF and CSV. So you can now export reports in any of these four formats, and you'll be able to see the report in them. So this is about report export. Now let's move to the demo. Now let's open up VS Code. So this is what the UI looks like. And if you see here on the left side, I've already imported my project, and I've already added my CF server, and the extension is already present. So all of my setup is already done. And now let me just run the analyzer and show you how it works. So all I do is right click on the folder, click on run analyzer, and since the number of files were 194, it ran within under a second. So this is what the UI looks like once I have the results ready. And here you can see there are 1296 issues, and the issues have been categorized. Like here you can see the high severity, we have 447 issues, we have medium, we have low, and we have the charts which depict the severity level, how many issues are for each of the severity. And we have attack types, and each of these attack types are color coded in different colors so that it's easier to understand. You can see for each individual attack types you will be able to see how many issues have been found. We have status, that is to fix, fixed, and ignored. And we have issue type, error, and warning. Now we have this security issues list as well. So for every single issue that it has flagged, you'll be able to see that in this list. Let us just open up one of them. Yeah. So we have one issue that it has reported, and it will show you the exact line number in which it is seeing the issue. It will also tell you the problem, and it will also suggest a solution for you here. And we also have a view file option. So let's click on this, and it will take me directly to that file where it is flagging uh, that in this line it is seeing the issue. And so if I hover over the actual place where the issue is there, it will give all of these details here as well, right? And let's talk about filtering. That is, so you can filter your data based on different criteria. For example, I only want to look at high issues. So I select high here, and I only want SQL injection. So I click this. You can see it's getting added to the filter. So you can also filter here as well. That is, I also want cryptography. So you can see cryptography has gotten added. So similarly, you can do for all of the different things here, and it gets added to the filter. And once you have added something to the filter, you can see that here the number of issues have reduced, right? Because the data that it is showing in the UI is based on the filter that you have added. Similarly, if you export a report now, you will be able to see only these filtered items. You will not be able to see all of the data. Only with the filter applied, what are the things that you are seeing, the same will be exported in the report as well. Let me clear this and export another report as well, just for comparison. Now coming back, let me open up both of these reports. We have first one and the second one. So as you can see in the report number 1, there are 145 errors, 0 warnings, and you can see the attack types that we selected in the filter: SQL injection, cryptography, and severity. We only selected the high one. So all of the filters that you've applied, you'll be able to see here, and the issues are also based on only the ones that you have selected. And if you come to the report where all of the vulnerabilities, so there are basically no filters in this, so everything will show up here. And you can see here the number of errors are 509, and there are 787 warnings. And so basically you can see all of the data here, but in case of filter applied, you will only be able to see the information around the filter applied. So these reports replicate the same format as you see in the UI. So you can see the graphs, you can see the list of all of the issues. So it maintains a similar kind of view. Now that we are already in the reports, let us export a report in PDF format. So earlier we had HTML and JSON which we were supporting, but we have also added PDF and CSV as well. So you can see that the report gets generated in PDF format, so that it's easy for you, to get the report in whichever format is it works for you. So in the similar way in PDF as well, we are maintaining the same kind of view. We have charts, we have all the list of the files with line numbers, with the attack type. So all of those are maintained in the exported report as well. The next one of the important things that I want to show here is the actions. So currently you can see that all of the issues that are mentioned here are currently in to fix form. That is, um, whenever we run the analyzer for the first time especially, and you have never marked any of the issues with any action, you will see every single issue in to fix state. That is, analyzer is telling all of these issues that I am showing you are actionable from your end. Now, once you look at the report, you see that, okay, this is something that I have already fixed, and I don't want this to be something that keeps getting flagged. So I've marked 4 of these as fixed, and this is the ignored action. And these 4 are the ones that really don't matter to us, and these are something, again, I don't want to see in every single scan report. So I've marked 4 of them as fixed and 4 of them as ignored. So currently you can see we had 1296 issues that were getting reported, and they were all in to fixed state, right? Now what I do is I run the analyzer again. And once I run the analyzer, you will see that the count has reduced here and in these graphs as well, because we are automatically applying a filter only to show the two fix issues, because that is what is actionable to you and that is what we believe is what matters to you in the first priority. So by default we show with the filter applied for in the two fix state. And of course we also give an option where you can go back and view the fixed and ignored list as well, so you can see them back here. And this state will get maintained when you're doing the next runs as well. So I've already marked 8 of them in fixed and ignored state. So in the upcoming runs as well, that state will get maintained unless you mark it back to to fix. So this is about action. I think this covers most of the things that we have added newly as part of this update. So I would suggest you try this out, install and add this extension, and you can try different things with the new, enhanced version of this analyzer that we have. So I would like to conclude this part of my session. And once again, thanks everyone for joining. And please drop whatever questions you have, and I will be answering those in the chat itself, because we will be continuing the session. Uh, and Rochelle will be talking about some of the new enhancements we have done in security and the posture hardening. So, all of these things will be covered by Rochelle. So, over to you, Rochelle.
Hi everyone, I'm Rochelle Hanna. I've been working with ColdFusion for the past 6.5 years now. I'm currently working as lead software engineer. Mega has already taken you through the security code analyzer. I'll be covering the remaining ColdFusion update security features that we have introduced. So, as you all know, security is no longer optional. Every week, we see headlines about data breaches, credential stuffing attacks, and compromised user accounts. So ColdFusion Update gives you production ready tools to address both of these threats without pulling in third party libraries. So here's what we'll be covering today. First, we'll look at the new password hash API, a unified way to generate and verify password hashes using Argon to bcrypt or scrypt. Then we'll switch to passkeys, a true passwordless authentication using the WebAuthn standard built right into CFML. Along the way, I'll do 3 live demos so you can see the code in action. Feel free to drop questions in the chat at any time. We'll have a dedicated Q&A at the end of the session. So, the first part is password hashing. Let's start with why this matters. Credential stuffing and database breaches are consistently the number one cause of account compromise. When attackers get a dump of your user table, the first thing they do is try to crack the password hashes. If you're still using MD5 or SHA-256 to hash passwords, and I know some of us are, those hashes can be cracked in seconds. A single modern graphics card can compute billions of MD5 hashes per second. That's not a theoretical risk, it's a practical everyday attack. This is where adaptive algorithms come in. Ergon 2, bcrypt, and scrypt are specifically designed for password hashing. They have built in cost factors, memory cost, CPU cost, parallelism that you can tune to make brute force attacks impractical. As hardware gets faster, you simply increase the cost parameters. So ColdFusion already supported bcrypt and scrypt algorithms, but with this ColdFusion update, we now ship a unified API that wraps all three algorithms behind two simple functions. You don't need to install any Java libraries. You don't need to manage dependency. It's right there in the box. You pick the algorithm, you tune the cost, and you're done. The entire hashing API boils down to two functions. That's it. Two functions. Password hash generate and password hash verify. So password hash generate takes a plain text password and returns a secure hash. And password hash verify takes a plain text password and a hash and returns true or false. So let's walk through the parameters. So for password hash generate, first we have password, a plain text string from your login form. Then the algorithm, the string, it can be argon to bcrypt or scrypt. This is case insensitive. If you leave it out, it defaults to argon 2. And then there is options. So optional struct where you can tune the cost factors. If you don't pass it, you get the sensible defaults that follow OWASP's recommendation. Then we have password hash verify. So it takes password, again the plain text to check, hash, this hash string from password hash generate, and then the algorithm. It's optional, same as above. That's it. Notice that password hash verify does not take option struct. It reads the cost parameters directly from the hash string. The hash is self-describing. So now let's look at Argon 2 options for password hash generate. So as I said, Argon 2 took on the password hash generate takes options as a struct. So we'll see the options available for Argon 2. So first is memory cost. That's how much RAM the hash computation must use. The default is 64 MB. This is what makes Argon resistant to GPU attacks. GPU have limited memory core. Then comes the CPU cost. It's the number of iterations. The default value is 3. Then parallel, that's the number of threads used. Default is 1. Then there's salt length, the size of auto-generated salt. The default is 16 bytes. And then the hash length. Length of the hash to be generated. Default is 32 bytes. So this is the beauty is you can accept all the defaults and you're ready. You're already secure. And these are the ranges that all these options take. Next, we'll be seeing the options for bcrypt and scrypt algorithm. So for bcrypt, there is round parameter, which defaults to 10, which means 2 to the power of 10 iterations, that is 1024 iterations. Each increment doubles the computation time. Going from 10 to 12 makes it 4x slower to crack. Then we also have version. It also takes version. So the default version is 2A. It also supports 2B and 2Y. Then we have script. So script is memory hard like Ergon 2 but older. The options are somewhat similar. It uses CPU cost, which must be in the power of 2. Then there is memory cost, parallel, salt length, key length. So instead of hash length, it's key length over here. So yeah, these are the options that are available. So enough with the slides. Let me show you this in action. So let's switch to the browser. So here is a simple app that is created to demonstrate the password hashing algorithms. So here we have generate hash button, which will call the password hash generate and generate the hash. And then we have verify password button, which will call password hash verify and verify the password against the hash. So yeah, let's get started. So here's the password right now that I've given, and algorithm is gone to. So when I click on generate hash, this is the output, and yeah, this is the argon2 hash string. Notice it embeds everything: the algorithm version, memory cost, time cost, parallelism, the salt, and the hash, all in one self-describing string. So you store this entire string in your database. And this is exactly why password hash verify doesn't need an option struct. It reads everything it needs right from the string. Now let's verify the same. The same password will be checked against the hash that is generated here. So I'm clicking on verify password, and as you can see, the password was verified successfully. So under the hood, ColdFusion passes the cost parameters from the hash string, recomputes the hash with the same salt, and compares. So now what if we type the wrong password? So let me just remove one character from it. So right now I'm going to verify the same old hash with this current password. So I'm clicking password verify. It's going to give password does not match the hash. So next we can try a different algorithm. So bcrypt algorithm, and here's what it generates. So if you notice, the bcrypt hash looks different. It starts with $2A, and it also includes the cost factor right in the string. So same principle, self-describing portable hash. Next we have script. So on generating, so this is the script hash that is generated. So here we can have like three. So here we have three different algorithms, just two functions, same simple API. So pick whichever your security team recommends, or just go with the Argon2 by default. So here you can compare the hashes generated for the same password. So the key takeaway from this demo is you are just two function calls away from industry standard password hashing. Generate takes the option to control cost. Verify just needs the password and the hash. It figures out the rest. No jar files, no configuration, no dependencies. And here's the code if you want to see. We are just calling password hash generate and passing the password with the algorithm. So this is the default one for Argon2, and here for bcrypt and scrypt. This is how password both the functions are called. So which algorithm is better if you ask? So here's a quick guide. So Argon2 is OWASP's top recommendation. It's memory hard, GPU resistant, the most modern option. If you're starting fresh, go with Argon2. It's the default for a reason. Bcrypt is battle tested, been around since 1999, still very good. If your security team already mandates Bcrypt, then you're fine. And coming to script, it's memory hard like Argon2, but Argon2 is considered the successor. Use script if you have existing script hashes to maintain. So now let's go back to the PPT. What if you're already using the old ColdFusion functions? Generate bcrypt hash, verify bcrypt hash, generate script hash, verify script hash. Good news, those old functions still work in with ColdFusion, nothing breaks. Hashes generated by old API can be verified with the new password hash verify function. Just pass the matching algorithm name. Going forward, use the new unified API for all new code. For a practical migration strategy, on next login, verify the old hash, then rehash with the new API, and then update the database. So that was it for password hashing. Okay. We just saw how to store passwords securely, but what if we could eliminate passwords entirely? That's where passkeys come in. A passkey is a passwordless authentication credential based on public key cryptography. specifically the FIDO2 or WebAuthn standard. Here's how it works at a high level. So when a user registers, their device generates a key pair, a private key and a public key. The private key never leaves the device. It lives in the TPM, the secure enclave or USB security key. The public key is sent to your server and stored. When the user logs in, the server sends a challenge, the device signs it with the private key, and the server verifies the signature with the stored public key. No password is ever transmitted, no password is ever stored. Here's a killer feature: passkeys are bound to the origin, the domain name of your site. If an attacker sets up phishing site at evilbank.com, the passkey credentials for realbank.com simply won't work there. The browser enforces this at the protocol level. This alone makes passkey a massive security upgrade over passwords. And this isn't a bleeding edge technology. Passkeys are supported by Windows Hello on Windows 10 and 11, Touch ID and Face ID on macOS and iOS, Android biometrics, hardware security keys like YubiKey. All major browsers, Chrome, Safari, Edge, Firefox supports it. Your user already have the hardware. This ColdFusion update gives you the server-side piece. Now let's see how registration and authentication actually works. WebAuthn has two ceremonies. Yes, that's the official term. So, a registration ceremony. So, this is how it works. So, we have server, browser, and authenticator. So, when the user clicks on like register passkey, the browser sends that request to the server. The server generates the challenge and sends that with the options to the browser. The browser then invokes navigator credentials.create on the authenticator. The authenticator creates a key pair, a private key and public key, and it also signs the challenge. And then that is sent back to only the public key and the signed challenge is sent back to the browser. The private key will be stored in the authenticator itself, and then the browser sends the public key plus the signed challenge to the server. The server verifies the challenge and with this and the signature, and also stores the public key. So this is how the registration ceremony works. Coming to the authentication ceremony, when the user clicks on login with passkey, the browser sends that request to the server. Server generates the challenge again with the options and sends it to the browser. The browser calls credentials get function, and the authenticator will verify the biometrics. It will sign the challenge using the private key and then send that to the browser. The browser sends it to the server, and the server will verify that challenge and verify the signature using the stored public key. So, this is how the authentication ceremony works. So, ColdFusion handles all the server side complexity. You call one function to start each ceremony and one function to get the result. So now let's see how CodeFusion 2025 implements this. There are three layers. So first is CFML functions. So that is your code. So there are three functions: passkey register, passkey authenticate, and passkey get result. These are the only three functions you need to call. Second layer is the passkey service layer. This is the CodeFusion internal layer. The passkey service handles the WebAuthn protocol, generating challenges, verifying attestations, and assertions. You never touch this layer directly. And then the third layer is the storage CFC. So this is where the credentials, that is the public key, are stored. So ColdFusion ships two implementations. One is the default passkey.cfc, that is the file-based storage, where the credentials are stored in the JSON file, and the second one is the database passkey.cfc, where it's stored in the database table. So both implement the ipasskey.cfc interface. So you can also write your own. So now let's see the first layer. Those were the functions. The entire passkey API is three functions. So passkey register, it takes user struct and config struct that is used to start the registration ceremony. Then comes passkey authenticate. It has user struct and config struct, starts the authentication ceremony. Then we have passkey get result, which retrieves the result after a ceremony is completed. So let's see what each of these struct takes. So the user struct for passkey registration, these are the keys that it has. First is the name. That's the only required field. So it's the username or email. This is the credential identifier. Then we have display name, which is a friendly name shown in the authenticator prompt. Then we have RP name, your application, that's your application name, relying party name. Then RPID, that's your domain. Usually CGI server name is given there. Then there's attestation. So how much information the authenticator should provide about itself, that is the attestation. So use none unless you need device attestation. Then there is authenticator attachment. So for to use Touch ID, Windows Hello, you can use the built-in one, that's platform. Or to use USB keys, you'll have to select cross-platform. And last we have user verification. If it's required, that means the user must verify with biometrics or PIN. So this was the user struct. Next we have the config struct. So config struct controls the flow. So first we have redirect URL, that is where to redirect after the ceremony completes. So usually after the login or registration is complete, we take to the page is redirected to home page. So that would be the redirect URL. Then there is service. So this is the CFC path for credential storage. That is where the public key should be stored. So default it is the file-based backend that we have. Then comes success handler or error handler. So these are optional JavaScript callback names. If you want to handle the result client side instead of via redirect. So next for passkey authenticate, again there are user struct and config struct, but user struct has just these three keys and config struct is similar to what we saw for registration. So after the ceremony completes and the user is redirect, you call passkey get result with the token from the URL. It returns a struct with these keys. So the struct will have the status, so success, if the registration or authentication was successful or not. So that's a Boolean value. Then there is action. It has registration or authentication. Then username, to know who just registered or logged in. Then there's credential ID, the unique credential identifier, then the message, error message if something went wrong. So that will be displayed there. So this is everything you need to update your session and log the user in. Next up, we have challenge store. The challenge store is where ColdFusion temporarily holds the challenges during registration and authentication ceremony. And what is a challenge? As we had seen in the registration and authentication ceremonies, a challenge is a random one-time value generated by the server that the client must sign and return to prove the identity. So for challenge store, you have three options. You can store it in memory, cache, or server cache. So in memory is for single server setups. So the challenge will be stored in JVM memory. For clustered environments, you can use cache, and if you want to use Redis, Memcache, or any other caching settings that you have already set in your administrator, you can use server cache. So you configure this in ColdFusion Administrator. So under security settings, we have these two new settings added. First is the challenge store drop down, and the second one is the challenge TTL, which is the time in seconds for the challenge to be valid on server and in the browser. These settings can be set using the admin API as well. So now that we saw what challenge store is and how to set that, now let's talk about where the passkey credentials are stored. So ColdFusion Update ships two backends. So first is file-based, that is default passkey.cfc. So using which the credentials are stored in a JSON file within CF root passkeys folder. It's perfect for development and testing. And this is the default one that is selected. The second one is database based. Here the credentials are stored on database. The passkey credential table is automatically created in your configured data source. This is what you'd use in production. And these are the list of DBs that are supported. To select the data source to be used, we have a drop down available in the administrator security settings page itself. So both implement the ipasskey.cfc interface, which is present in the same folder. So if you need something, if you need to customize something, say storing credentials in Redis or maybe in NoSQL database, you can write your own CFC that implements the same interface and point to it in the config. Now let's see a demo for passkey registration and authentication. Okay, so as you can see, I have pages for registration, authentication, and to get the result. So first, let's see passkey registration. So this is just the description on how the passkey registration some ceremony happens. So which I had already explained. So you can just go through this if you want to. So first, let's see how to register. So before showing the demo, I'll just show you the code. So here I'm calling passkey register function and I'm passing these values to the user struct and to the config struct. These are the values. So redirect URL will be taking on registration successful or failure. It is going to redirect to this particular URL. And here, yeah, once passkey registered is called, then I'll have to just start registration, and that's how we register. So here the username or the email ID that I want to register is demo@example.com. So let me register. Okay, let me register with demo1.example because I think I have already registered with demo. So demo1 is here. Let me continue with the authenticator. I just have to give my biometrics, and here's the registration that was successful. So action registration, username, credential ID, and user ID. These are the values that were received from passkey get result. So as you can see, the URL that got redirected and also the passkey token has been sent here. So this token has been sent to passkey get result, and this is where we got the result. So this was for registration. Next up, we have authentication. So here's the code for passkey authentication. I'm just passing this thing and redirect URL will be the same. So let me sign in with passkey. So on authentication, I am selecting demo one because that was the one that I just registered. I'll have to just give my fingerprint and authentication is successful. Again, these are the similar things that we get from passkey get result. So this is how passkey feature works. No password was typed, no password was transmitted, no password was stored. This is what passwordless authentication and register looks like with the ColdFusion new update. That was it for the passkey feature. Coming to the last part of the session, that is the security posture hardening. As part of posture hardening, we focused on key vulnerability areas, including XSS, XXC, deserialization issues, and path traversal, while also addressing legacy risks and strengthening secure coding practices across the platform. Uh, and with this update, also includes a broad set of security and stability focused OEM upgrades across. These upgrades primarily addresses known CVEs and harden the platform, align with current vendor supported versions, and prepare ColdFusion for newer AI, cloud, and integration features. So total 33 OEMs were picked, out of which 9 were critical, 16 were high, and 8 were medium. And the notable OEM upgrades in this release are SharePoint revamp from Access 1 to Apache CXF, then JNBridge upgrade, Solar upgrade, Tomcat upgrade, and HTTP client upgrade. So that's all I had for today's session. I'll be taking your questions in the chat. Thank you, everyone.